Students, so today we are talking about how to make sure that your rocket design is safe to fly, and we're going to be using a program called OpenRocket to help us calculate this. One challenge is that if we make a rocket and we glue on the tail fins and everything and then it's not safe to fly, we basically have ruined all of our material and we have to start over, which is really bad news. So we are going to use OpenRocket to kind of calculate whether or not it's safe to fly. To be able to do that, we need to know the term center of gravity and center of pressure. So center of gravity is what we usually think of when we think of balancing something, and you have the same amount of weight on one side of that point as you do on the other. And so if you have a teeter-totter and you have one kid and one kid on both sides, it's going to be balanced. Or if you have a big kid and a little kid, you're going to have to scoot that big kid farther forward or move over kind of that balancing point until it's equal on both sides. Or the leverage, calculates that. But basically, same weight on both sides is kind of what we're thinking about here. So center of pressure is when you have wind, and we're kind of calculating the same thing as center of gravity, but instead of weight and gravity, we're talking about wind resistance. So if you look at this shape, this red dot would be the center of pressure, and on the left side you have a lot more rocket, but it's kind of smooth and skinny. To the right side we have these fins that are going to catch air, and so that's going to move the center of pressure farther back where you catch more air. Well, it's kind of the same, basically the same thing here, where the balancing point for the wind is this red dot. All right, and so our fin design can greatly change that, and we need to change our fins based on, anyway, to make sure that the center pressure is behind the center of gravity. And as long as we have this center pressure to the right side of the center of gravity behind it, then it will be safe to fly. So we're going to use OpenRocket. OpenRocket is going to look like this, and you're going to start off, it's going to be blank. OpenRocket is a free program, and you can download this at home if you have a home computer and your parents are okay with it. You go to the internet, you type in OpenRocket, and it'll pull up a website called openrocket.info, and you download the program. It's totally free. You don't have to register it or anything. And it's a great program. We can build a rocket exactly like we have designed in Shaper 3D and what we have printed and started building. So we got to start with a component, and you can see here that it says sustainer. That's basically your rocket overall. We're going to click on sustainer, and we're going to add a component. We need to start with the body tube, and you can see here that when I click on body tube, it's going to open up a bunch of different manufacturers. We buy our body tubes. We don't make them, so we can just pre-select one, the right one that we have purchased. And this one is a BT. The ones that we are using are BT50, and they come stock 18 inches. If you cut it, you're going to have to change that, but it's going to come like this. It's going to be body tube. Let's see, that's a BT5. That's not right. This is BT50, and then 18 inches. That's the one that we want. And then we'll say close. And at this point, we have the ability to change measurements if we need to. You can change these measurements from inches to millimeters, and then you can type something in, and we can say okay. And then down in this box down here, you see this big blue rectangle that represents our body tube. Now, we can add different things to the body tube, such as a nose cone. Make sure you have selected body tube. And then we did not purchase one, we made one. So what we're going to do is we're going to just select one of these. It doesn't really matter, maybe this one right here. And then we're going to put it in. You can see here down below that is not the right shape. It's way bigger than this body tube. That's not right. But we can change it now. We can change the name. Maybe I would change it to Fox Nose Cone. You can change the shape. It gives you a little bit of the ability to kind of change that, and I'll make another video about how to do that. But for example, base diameter, I can type in millimeters and change it to 23.8, and that's going to be the right size for the diameter. But now you can see that is too far back. It's actually at the end of our rocket, not at the front. So what I can do is top left corner box here, I can click on Fox Nose Cone, and I can move it up. And so that way it's in front of the body tube, and now it's in the front. Okay. If I want to add fins, I'm not going to click on the nose cone because I don't want to add them to the nose cone. I want to add it to the body tube. I'm going to select body tube, and I'm going to click on fins, and there are different types of fins. For right now, I'm just going to say trapezoidal, and you can kind of change the shape of those if you want to. And as you change the shape, if I make this smaller so you can see that as I change the shape, it changes the center of gravity and it changes the center of pressure. This would be a really bad fin design because it moves the center of gravity way back, so it's just right barely in front of the center of pressure. That would be bad. All right, so with that being said, there are different things that we're going to add, and we're going to do it in the right order. If we don't do it in the right order, we're going to have a problem. We're going to start with the body tube. We'll add a nose cone, then we'll add motor mounts, we'll add an engine, we'll add shock cord and parachute. And then after we add all of this, at the very, very end, we're actually going to add our fins. So even though I just added fins to show you how to do that, you would do that last. And the reason for that is we want to make sure that we get all of our weight in this rocket, and then we can design fins that are going to be safe to fly. And you're going to start with the design that you already created in Shaper 3D, and then we'll need to tweak it if it's not safe, and then reprint. And then there's one final thing that I just want to remind you. Your measurements in OpenRocket must be exactly the same as in real life. In other words, as in Shaper 3D. And so there are different ways that we can do that. I'm going to make a rocket that looks similar to this. And so I'm going to have a nose cone like that, and I'm going to have some fins maybe that look like this. This is just as an example. And then one way is I can kind of click here, and I can get my measurements down here. So my diameter of that is 23.8. And then if I wanted to, if I wanted to see how tall it is, I could probably try to maybe select this and see if that will tell me how tall it is from this point to this point. Unfortunately, that's not showing up. And so there's another way that we can do this that is actually a lot easier than selecting each of these points and then seeing the measurements of those. And that is using architectural plans or drawings. You can do this in Shaper 3D. It's actually really cool, really easy. And I'll make another video showing you how to do that. But it's going to like print pictures of your design from different angles. And you have the ability to get measurements that will tell you exactly how big that is. So for example, the bottom part of my nose cone design is 23.8. Notice that it's using a comma. Around the world outside of the US, in a lot of places, instead of using a decimal point, it uses a comma. So 23.8 would be 23 and then a comma and then an 8. And then in our place where we use a comma, for example, 2002,000, it would use a decimal point instead of a comma. So that can be a little bit confusing. You can change that in Shaper 3D. I haven't done that, so I'm getting these commas. But you can see exactly the measurement. So between this point, this line, and this line, it's 5. Between this point and then this point right here, that's 55. And then, coming all the way down here would be 55 plus 5, which would be 60. And then you can get a measurement, okay, between this point and this point right here, that's another 10. So from top to bottom, it's actually a full 70 millimeters. From this point down to this point right here, it's 46.83. And then from this point to this point, it's 14.4. And so this is going to make it a lot easier if you know how to do architectural drawings. It's going to make it a lot easier for you to use OpenRocket. All right, that's the basic overview of OpenRocket, what we're doing, and the things to keep in mind. Remember that the steps here: body tube, then nose cone, then motor mount, then engine, then shock cord, then parachute. You're going to be adding these to OpenRocket before you add your fins, right? Remember that all measurements in OpenRocket must be exactly the same as in real life. All right, check out the other videos.